Hello, everyone, and thanks for joining us for our Safety and Health webinar today, sponsored by Protective Industrial Products. We're going to let our audience settle in for just a few minutes here, and we'll start the presentation shortly. Thank you. Thank you all for joining us again today for our Safety and Health Magazine webcast. We're going to let everyone settle in for just a few moments here, and we'll get the presentation started very shortly. Thanks. Well, hello, everyone, and welcome to today's Safety and Health Magazine webcast, Common Welding Hand and Body Hazards, and the PPE Solutions That Protect, sponsored by Protective Industrial Products. My name is Barry Botino, and I am an Associate Editor with Safety and Health. I'll be moderating today's event. Before we get started, I have a few housekeeping items to share with you. As a disclaimer, the views of today's speakers and organization are their own and do not necessarily reflect those of the National Safety Council or Safety and Health Magazine. Any mention of a commercial enterprise, product, or publication does not mean the council or the magazine endorses those items. After today's presentation, we'll conduct a Q&A with our speakers. If you have a question, just click on the Q&A button located at the bottom of your screen. Go ahead and type in your question and press the send button. You do not have to wait for the Q&A to begin to send a question. After this presentation, you'll be asked to complete a brief evaluation survey, but I'll tell you more about that a little bit later. This webcast will be archived, so you can access it after today's live event. To view this webcast and all of our past webcasts, please visit us at safetyandhealthmagazine.com/events, or you'll also receive a link in our post-event email. With that, let's introduce our presenters. With us today are Brian Rush, Paul Sung, and Jim Hebner. Brian is a product sales manager with Protective Industrial Products and has 17 years of experience in welding distribution, welding equipment manufacturing, and welding PPE. Paul's career includes 25 years of work in glove manufacturing and distribution. He works with other field sales personnel and customers regarding welding protection in his role as a product sales manager. Jim serves the company as its marketing channel manager. His experience in the industry spans 12 years in welding distribution and welding PPE. He currently creates educational content for distributors and end users. Again, we thank you all for tuning into this presentation today. And Jim, whenever you're ready, go ahead and take it away.
Sounds good, Barry. Thanks for kicking things off. And thanks everyone for taking the time out of your busy schedules to join us today. Let's get started. Here's the agenda showing the 5 main sections that we'll be covering. I will get things started with industries and key organizations, as well as regulations and process standards. I will then turn it over to Brian, who will cover hand protection hazards and PPE solutions. And then we'll turn it over to Paul to discuss body protection hazards and PPE solutions, and then wrap up with some key innovations in welding protection. There is welding being done in every one of these industries shown, some more than others. The key industries include shipbuilding and construction. Kind of a key fact, welding affects an estimated 50% of the United States gross national product. It is important to note every welding environment is unique and needs to be evaluated by a qualified safety professional or certified industrial hygienist for regulatory compliance and risk reduction. You can check out the PIP website for tools to help with product recommendations. Let's identify some of the key organizations impacting regulations. You are most likely familiar with the list that's here. To assess health and safety risks when welding, it is important to become familiar with the pertinent health and safety regulations. AWS and GATA are two key organizations that impact welding processes and regulations. We recommend you visit their websites if you are looking for more information. Okay, now I'm going to point out some key regulations. I'm not going to read the entire regulation or I'd pretty much put you all to sleep. The 29 Code of Federal Regulations 1910 deals with the health and safety standards. Subpart Q has a general standard regarding welding, cutting, and brazing. General information regarding combustible materials, fire watches, and areas where welding is prohibited. There is also standards governing oxy-fuel welding and cutting in the storage of cylinders, as well as standards governing arc welding and cutting. Subpart I focuses in on the hazards hands are exposed to, such as cuts or lacerations, abrasions, punctures, and burns. All hazards we'll spend time discussing further in this presentation. Here are a few examples of ANSI and OSHA standards. As you can see, these standards provide vague explanations on what actual hand and clothing protection is needed. Kidding aside, none of the current standards get into specifics on what to wear. That's pretty much one of the goals of the primary goal of this presentation is to provide you with those recommendations. Here are some additional standards focused on protective clothing. ASTM 6413 is the standard test method for flame resistance of textiles. ASTM F1506 is the governing ASTM standard for flame resistant clothing. The National Fire Protection Association 2112 standard and NFPA 70E. Keep in mind that PIP is testing to these standards. Now I will turn it over to Brian Rush to cover hand protection, hazards, and solutions. Take it away, Brian.
Thanks, Jim. You know, why don't we start this off? Maybe we should start with one of our first poll questions. I'll give you guys a few seconds to answer this before we jump into hand protection a little bit further. And again, can't thank you enough for joining us today. All right, let us begin. So one of the things about hand protection is that, kind of to reinforce what Jim had said, you know, it all comes down to what's really happening. And here's some injury statistics. And what we have learned through, you know, our network of safety folks throughout this entire industry is that the majority of injuries happen when they're not wearing a glove. They take a glove off to go do another job, even driving, say, a fork truck. Oh, I don't need to wear my gloves to do that. I'm just going to drive across the plant. I'll be fine. And then boom, an injury happens. The other thing is, I think right now, all of us on the call can understand we have never paid more attention to safety except for when we've all been, what we all went through with COVID. Safety has become a major part of our lives every single day with everything that we've done. And the wild thing, which we don't have a stat on the various end users that we work with and the distributors, injuries specific to welding in other areas have actually started to increase because more people are concerned about an inhalation hazard than what they're wearing on their hands to protect from a cut or a burn. You know, let's talk about applications. When welding, well, the funny part is welding is just one piece of the fabrication process. People are doing all of these jobs. There are very few jobs out there where someone is actually welding from the start of their shift to the very end of the day. There's a lot of people out there that are setting up machines. They're grinding, they're cutting, they're driving a fork truck, they're grabbing the metal. And what we're trying to do in Whole is really the education of gloves need to be developed and innovations need to be made to not have to change to a different glove. One glove can do everything. So how do you select the right glove? You know, is it hot work? Is it cold? Or is it inside? Is it outside? What kind of materials are, you know, really actually do better than others? And part of that we're going to get into today. You know, identifying hazards. You know, hot metal doesn't have to glow red. Gloves that fit poorly are actually not just cumbersome, they're uncomfortable, and it can take away from actually getting the overall job done because it's distracting. Then the other thing is, what's wrong with wearing something that's cool? It doesn't have to be expensive, but maybe have a little style involved with it that actually, when the worker looks down at their hands and says, you know what, these are pretty nice. And then the other thing is, a lot of welders wear gloves that literally look like they are burnt to a crisp. And the answer that you will hear is, well, I just got broke in. So let's talk about hazards specifically. Some are obvious, some are less obvious. Sparks and spatter slag, that's a part of the welding world. That's cutting steel with a torch. That's welding it, regardless whether it's stick, MIG, or TIG. But back to what I said about hot metal. It can still be hot enough to injure you severely without it glowing. And then one of the things a lot of people don't think about is ultraviolet radiation. The funny thing is, welding is very similar to standing out in the sun all day long without sunscreen. And then the electrical shock component has increased tenfold after the last few years, because if you're welding, say it's 100 degrees outside, you're in the sun, it's hot. Welders usually have, and I have seen this, I'm sure some of you have, they're not really wearing the right stuff. So that all equals a burn. So causes of burns. Basically, we've broken it down to two things. If you touch it, or it's hot enough that you're just near it and it's affecting you. So conductive is really this, a piece of spark jumps off and goes down the back of your jacket or your shirt even. You're going to get immediately burned by that hot ember. You know, then we talk about radiant, back to what I was stating about kind of the UV type radiation. You're not necessarily touching it, but you're close enough that it's hot enough to actually affect your gloves. For instance, a lot of injuries happen when, say, a split cowhide stick glove gets really hot, it starts to shrink. And when it shrinks and it happens to come in contact with your skin because it is basically tightening up, you can get burned even though you are physically not touching something that's hot other than the glove itself. So let's talk about the electrical component. Arc ratings have become almost a standard now in welding because it is an electrical component. That a welding machine is producing electricity. It happens to also be in coordination with fire and sparks. So here's the rating system. Now, PIP uses the term PPE. It can also be known as the arc rating itself. And here is the minimum calories per centimeter square to fit within that category. And the big part is, and for you guys out there, what are the components of testing gloves? This one happens to be, I would call, extremely important these days because of welding being an electrical operation. This helps with reducing injuries based off of the type of welding that they're doing and the type of amps or volts that they're using. So let's talk about glove materials. In a nutshell, what's the animal? So One of the things about the animal hide itself, the reaction to heat from what you see in front of you is dramatically different. Let's talk about, I'm just going to kind of get out what's the two most commonly used hides for welding gloves. Cowhide and then goat skin. But we're going to talk about the others as well. Cowhide is in split format. It has different grades. We're not going to dive into the grading system. We'd be here all day long and you guys would be asleep within a couple minutes. But cowhide is inexpensive and also is goat skin. But that's also one of the reasons why it's so widely used as say a stick glove in a split type format. Grain cowhide is, again, the same thing. It's just a different piece of the hide itself. But keep in mind, you're going to see a lot of cowhide gloves if you're shopping or you're even selling or looking to procure. Deerskin is by far the biggest improvement using and being involved with a deerskin glove. And it, by the way, is typically seen in a split format. It is extremely soft. It is so comfortable. It's so nice on the hands compared to a cowhide glove. It's typically used in TIG welding and even some light MIG. It doesn't do an awesome job with high heat applications, and thus is why we're bringing it up for TIG and MIG being a lighter duty type MIG welding. And then the absolute almost gem when welding, and this is a popular one used by stick welders, especially pipeliners, is elk. Elk is like the Lamborghini and Ferrari of animal hides when you're talking welding gloves. One, it's as or can be softer than deer with twice or three times the durability of deer. The other thing about it with heat, it doesn't shrink up like cowhide does. It still remains supple and usable. It's extremely common, again, as I said, in stick welding as well as MIG. And then we get to pig. Hey, who doesn't like bacon? But when you put that into a glove, let's just put pig skin, especially for abrasion resistance, it's at the top of the charts. If you have kind of almost wet and oily environment, pig is ideal. It actually has a bit of water and oil repellency to it naturally. And again, back to the abrasion, if you have a high abrasion, say you have someone who's doing just as much grinding as welding, go with pig skin. And then goat. Goat is, again, you can get goat very, very, very thin for ultimate dexterity and tactility. Goat is the way to go. It is by far dominates the TIG welding world and most of the lower amp / bolt welding for MIG. And then silicone. This is the new up and coming thing. I don't know if you know someone or maybe you have this at home. Have you ever seen a silicone oven mitt? That is why silicone has become so popular, in particular components of gloves, being the back of the hand bump protection, which actually we're going to talk about here fairly soon. And plus it repels water. It's going to bead up on it. So linings. This is really about as simple as it gets. Wool, cotton and foam, and cotton. Wool is the best. It has the best insulation you can get in a glove. It wicks moisture. It actually is inherently fire / flame resistant. And that's, again, it's a natural fiber. In some cases, specifically wool compared to, say, Nomex, the cost of wool is 1/10 of Nomex. Cotton and foam, another good substitute to wool. Cottons and foams are actually usually glued together. You see that commonly in a stick glove. Stick gloves predominantly are either cotton and foam or cotton. The usual reason why someone would pick cotton and foam over just a cotton liner, it's all about heat. And then basic, just a cotton liner. The cotton liners are usually between 1 to 2 mil thick, but that's when you want more dexterity. So let's talk about kind of the up and comer, cuts. It's not just sharp objects and jagged surfaces. It's where are those existing? Number one, let's talk about the first thing you do after you grab a piece of steel that you're going to start and want to weld with and weld on. You're going to have to pick it up. You're going to have to put that in some sort of a saw or a table. Well, those sheets are normally, or rolls or steel blocks. They're not finished. It's rough. They have sharp edges, can have jagged surfaces. Then let's jump ahead. So you're having to use them with a chop saw or even a cutting table. You're pulling stuff off. You're likely using a welding glove. The other part is look at the kind of towards the end of the process, the grinding. You can have just as much, if not more, of a severe injury grinding than when you're handling the metal initially. Thus, cuts have become a very, very big deal. So what is ANSI cut ratings? What is this all about? We put some of the grams on here of pressure for you to kind of understand something, but we wanted you to understand because we're starting to see more and more of this. ANSI is a US standard for cut protection. You will see likely gloves out there with EN being a European type standard for testing. They are, and they don't necessarily correlate what the numbers are to an ANSI bona fide test with an ANSI A type score. So let's talk about impact. This is another one that is becoming widely seen, and that is, again, back to what we talked about. When do people get injured? It's when they take the gloves off. Now welding gloves are being designed with impact protection. Sometimes it is what we call a TPR, which is a thermoplastic rubber that's been treated, even a silicone material. And then you also have pinching. So say, for instance, you're welding a beam and you need to roll it over, or someone's helping you and they're not paying attention. What happens? Number one, you're going to crush your fingers. There's a lot of folks out there I know involved in the gas world that are rolling cylinders. If you're new, you're pretty much guaranteed to smash your pinky. And that's just rolling cylinders, which a welder will be doing at their shop. So here is the ANSI rated scale. There's a 1, there's a 2, and there's a 3. 3 is becoming a lot more popular. The one big thing about this is, by the way, so what makes a 1, a 2, and a 3? What is going to really give you the most protection? Number one, the 3 is the highest and the thickest protection level right now that's available. A 1 is typically about 2 millimeters thick. A level 2 puts the material between 3 to 5 millimeters thick. And a 3 is a 7 millimeter thick back of the hand rubber type protection or silicone. Thank you for the time today, Paul. Take it away.
Brian. And I think at this point, we have another poll question for you guys. So if you could take a little bit of time, just read the poll and just answer on your own, and we'll give you a few minutes. All right, so I think that's enough time. So now, hey, thanks, Brian, to going over all the gloves and all the hazards, and same to you, Jim. So now we're going to get into welding clothing. So just like gloves, hey, it's another component. It's another piece of PPE that a welder is going to wear. First thing that we try to teach people is, hey, understanding the environment. So we basically went through, and here's some 4 basic steps to create a flame-resistant clothing program. So there's a ton of hazards out there. Brian went through them, and we're going to briefly go through them again. But again, you definitely got to identify the hazards in the workplace. And then you definitely want to make your next step to perform some sort of hazard assessment. And just like we said before, to have some sort of a hazard assessment, you do have to understand the standards and regulations out there. The next step is going to be to select some sort of fabric, and we'll go over those types of fabrics in a few slides. And lastly, it's really important to make it aware to your workforce how important protective clothing is for the workplace, especially in the welding environment. So again, we're going to briefly go over these because Brian just went through these. But again, the hazards found for glove protection or hand protection is no different when it comes to the body and the garment. So the most popular ones that are quite common, not popular, but the common ones are in the welding environment is going to be the sparks, the spatter, the hot metal, the flash fire, shock, as well as the radiation. So again, all this encompasses the type of hazards that cause burns. Next, we'll go over some of the cuts to the body, is, torso cuts, jagged edges on the workplace. So as I said before, here's some choices when it comes to the different types of fabrics found on the jackets. So the first one's going to be a cotton twill. This is your, as you would say, your economic type of protection. It's low cost. There's not a whole lot of durability. It is going to be kind of a light duty protection, simple as that. The next step would be some sort of a sateen. Sateen is a little bit different than the twill. So if you can imagine a fabric, the twill's going to have, if you look at it closely, it has like these ridges, a corded material. Sateen is pretty flat. It's quite, there's a slickness to it. So if you can imagine a piece of spatter falls onto a twill material, it could kind of catch. Why? Because it has those ridges, it has those cords. On a sateen, it has more chance of just kind of a shedding type of action. It doesn't really catch onto the material. Sateen is a little bit more medium duty. It costs a little bit more, but also there is a little bit more durability as well. And lastly, the most common that we see in the workplace is leather. There are different types of leathers. We'll go through that in a little bit, but this is going to be required where there's a lot of heat, a lot of spatter. There's a lot of factors, a lot of hazards. This is what we call a very heavy duty type of material. These are some of the leather garments in the workplace as well as the other FR materials. So the first one's going to be a basic apron. The next one is what we call a combo cape sleeve. So now we're combining the FR cotton with leather sleeves. And of course, the picture next to that, that's the bib that's going to go onto the cape sleeve front. And we also have chaps. Those are very common as well in the workplace. So there's another component to the garment. So we basically covered various jackets, chaps, aprons. Now we're going to talk a little bit about sleeves. In the sleeves, there are the similar type of materials. Would it be the twill cotton, the sateen cotton, and the leather? But now we've added another component or another material, and that's going to be Kevlar. And you guys are familiar with Kevlar. Again, it's a little bit more of an expensive material, but there are definitely advantages of it. It's FR, flame resistant. There's some heat resistance to it as well. Here's some examples of these sleeves. So on the left-hand side, we have a twill material. The next one's going to be a sateen. We have a Kevlar and leather sleeve, and then we have a full leather sleeve. So the thing that I want to point out here is on the Kevlar leather sleeve, again, there's kind of a double duty here. There's actually some cut resistance. This particular item is actually an A3 level, but it also is FR like I mentioned before. So now we're going to talk a little bit about welding glove innovations. This is an interesting topic, just because when I think about welding gloves or anybody who's seen welding gloves, it's there hasn't been a whole lot of innovation for the past 40 years or so. Other components within the welding application, there has been a lot of innovation. But before we go into that, there's another poll question up on the screen. If you guys could take a quick minute. Thanks, guys. So let's dive into some of the welding glove innovations. So like I said, there hasn't been a ton of innovation with 40 years. So it was important, just like anybody else, anybody who's going to do a little bit of research, they're going to go out and talk to the welders. And what we found out was there's a lot of welders out there that are looking a little bit more for performance, something that really hasn't been addressed. And part of that performance has to do with comfort and fit. So what we want to talk a little bit right now is going to be the PIP Caiman Contour. Well, what is Contour? Well, what we found was important is we wanted to create a product that truly matches all these different angles, these shapes, these crease lines of the hand. So it seems common sense in a glove, it should address those things. But in welding gloves, for most part of 40 years, they're really based on a two-dimensional design. You put a welding glove on a table, it lays flat. You look at your hand, hey, your hand isn't flat. There's a lot of nuance to it. So the Caiman Contour, the first thing it does, it addresses this natural curvature. We don't walk around. If you look down at your hands are generally curved. And again, the Caiman Contour addresses this curve. Also, if you look at the middle picture, if you look at the palm, you have this crease line at the base of your fingers. Most two-dimensional design gloves are cut straight across. Caiman Contour actually addresses this curve. In the last photo, if you look between your fingers, you see this slope. The Caiman Contour addresses this slope. And again, all Caiman Contour does is try to match the glove to the actual hand. And we'll talk a little bit about some of these exclusive features that are found in the PIP Caiman line. The first picture shows these patches, and within the patches, within the photo, you could see some of these notches. Well, all the patches on the gloves are made in a way to work with the movement of the hands. So to fortify a glove, it's really easy to add leather here and there or other materials to make it more durable. Well, when you add a lot of material or more material, you're gonna get a chance to impede the flex of the glove. We make sure that all the patches on the gloves are engineered a certain way where it doesn't, it provides still that dexterity that welders are looking for. The next item is going to be our patented contour wrist. It's going to be a little bit hard to explain without showing or even a video, but basically like the contour pattern design, we're addressing this curve. With the contour wrist, now we could accentuate the curve from the tip of the fingers all the way to the end of the cuff. Again, this is the natural position of a welder. Next is going to be the exclusive engineered seams. So if you think about it, the seams are the weakest point of a glove, and that side seam on traditional welding gloves is right on the area where there's a high abrasion. So in this photo, you can see the red dots. That's the traditional line of a glove, the seam. A lot of the Caiman products, we've moved that seam a little bit slightly above, away, and on the back of the hand, so it's not getting worn down. And in this particular glove, instead of the seam, now we have a piece of leather, a reinforcement piece of leather in that spot. And in the far right, we started to add padded palms. Again, this is not a huge feature, but this is addressing the comfort that a lot of welders are looking for. Here, we're also going to stop for a minute. Oh, I'm sorry, not on this slide, sorry. So let's talk about a little bit more about innovations in welding gloves, and in particular, cut resistance. It's becoming very popular among welders. There's a cry out there that, hey, we're using a lot of metal, it's a lot of sharp objects, we need some sort of cut resistance. So here are a few Caiman cut resistant gloves. All these are A5 level. The glove on the far left, that is based on a quite popular glove. And what's unique about this glove is you could see that it's longer. Well, it's actually 21 inches in length. So this particular glove is a glove and sleeve in one. The next two gloves are MIG/stick welding gloves. Again, A5 level. The far right glove, that is a glove that we call a fabricator's glove or a TIG welder's glove. There's a lot of dexterity, there's a lot of tactile sensitivity, and again, this is an A5 level. We'll go into a little bit more about these innovative cut-resistant gloves in the Iron Cat line. All these gloves that you see are A4 level. And there's some extra icons on the bottom. Now we've also tested for arc rating in these particular gloves. So the first glove is not only A4, but it's PPE level 4 for arc rating. It's a stick welding glove. As we work through the line from left to right, the next two are going to be MIG style gloves. One is a PPE 2, the other is a 3. And I'm going to jump over the next glove and go to the far right. That's going to be a basic driver's glove, often found in every single fab shop. This again is A4, PPE 3. I'll jump back to the other glove, the black and white one. This one I want to spend a little bit of extra time. This is a quite innovative glove. Again, PPE 3, A4, cut resistance, but what makes this so unique is the impact protection that Brian spoke of earlier. This has the TPR on the back. It's a impact level 2. This is a glove that has a lot of dexterity, and as you can tell, it has a lot of protection as well. The next section we'll cover is going to be innovative welding garments. So we covered some gloves, and now we're going to talk a little bit about the garments and what has changed in the industry. And again, it's no different. For many years, things have been the same. So recently, Boarhide has come out. Boarhide is basically a garment grade pigskin. So the traditional leather garment in the industry is going to be cow split leather, very common. So after talking to welders, seeing what their needs are, what they would like to see as far as changes and innovation. Welders are in an environment that is very hot. If you think about a welder who's welding in the South where it's humid, temperatures are out of the roof, now you're asking them to wear not just gloves, not a welding helmet, but all this protective clothing. And that can get quite stifling. So how do we make a garment more comfortable, just as protective, if not more protective, and much lighter as far as breathability? So Boarhide, like I said, is a garment grade pigskin. The natural characteristic of Boarhide is that it's it has a much tighter fiber than cowhide. So being that it's much tighter, it has more strength. So we can actually make the leather thinner to make it lighter weight. So again, promoting comfort, airiness, lightweight. Not only that, but Boarhide is also very highly abrasion resistant. It's more breathable than cowhide. And another nice benefit of it, there's elasticity to Boarhide, whereas cowhide doesn't stretch at all. And now I'm going to turn it over to Barry because I think we might have some questions to answer.
Well, thank you very much, Paul. I appreciate that. And thank you, gentlemen, for sharing your insights with us today on this topic. Just a reminder for our attendees to get your questions in, go ahead and click on that Q&A button at the bottom of your screen. If we don't get to your question today, all unanswered questions will be forwarded along to our speakers. Before we start the Q&A, I do want to mention to everyone about our evaluation survey that we're asking you to complete today. The survey will open in a different screen after this webinar. Your input is really important to us as it does help us to improve our future webcasts. Now let's go ahead and get to some of those questions. I wanted to start with question from our audience for Jim. Someone mentioned aramid fabrics, and I wanted to know what's the difference between, say, aramid and Kevlar fibers, and what do the two provide?
Thanks, Barry. Yeah, let me cover that. Actually, they're synonymous. Aramid is a general term, and Kevlar is an actual brand name. It's kind of similar to facial tissue and Kleenex. The other one is, yeah, what do they do? They're both types of fibers that provide strength as well as heat and flame resistance.
Great, thank you for that, Jim. Next, I want to go to Paul. And Paul, we had a question that came in regarding the price difference between cowhide and boarhide garments, and is there a difference there?
Yes, there is a difference. Boarhide garments going to be a little bit more. For the most part, out in the retail, pricing is about, let's say, depending on the retailer, maybe about 15, maybe 20% higher when it comes to the boarhide. But again, the benefits far outweigh, I think, the cost difference, and that's what we're seeing.
Great, thank you for that. Brian, I wanted to ask you, we had a question come in about which glove materials are typically have the best heat properties?
I'd probably have to go with animal hide wise. It's going to come down to the thickness of the hide itself, but elk seems to do a much better job at keeping heat off of the hand than cowhide. The cell structure of the hide itself is dramatically different for elk compared to cowhide. It's there's a lot, actually, substantial less amount of hair follicles, which is typically what causes the heat to get through the leather, where the liner itself plays a part. I hope that answers your question.
Okay, thank you for that. Paul, next question for you. Which sleeve materials are best for protection against UV rays that are emitted from welding?
Well, I think all of them do a pretty good job. Now, I think the best one is going to be some sort of leather. Simple.
Great. And Brian, we had a question come in for you. Is a stick glove typically only used for stick welding?
One of my, I love this question. I get it often, and the answer is no. And I'm going to explain that. A stick glove can be used for MIG welding. It can be used for gas cutting with torches or plasma, although you may not use it for that because the dexterity is horrible compared to even a MIG glove. But what we advise, and kind of where I tell people, is stick can handle a lot more heat than a common, normal, everyday type of MIG glove. Whenever you're using a gas torch, even a grinder, the thicker the material, which you'll find in a stick glove, is actually going to help and benefit you from an injury perspective. Say where a grinding or a cutting wheel on a grinder were to explode, especially in welding and high amp welding, we always recommend start with a stick glove, because then as your amp and volt ranges go down, you can start basically working off the fact that if you're not feeling anything, then the glove is doing its job. I hope that answers your question.
Great. We just had a question come in that I wanted to throw out to everyone in the group here. What is the best both glove and material for plasma cutting?
Paul, Jim, I can answer this one. So that's going to come down to predominantly the amp range. And I hate to tell you to go to our website for more information, but that's a great place to go in the welding selector guide. But I'm going to answer you now. Let's just say, for instance, you're looking at using a plasma torch at, say, 20 amps, which is fairly low. A MIG glove would do you fine with that, because again, it's the heat level in the hand and the handle of the plasma gun is low. What really happens is it's the type of material you're cutting is going to produce that a different amount of sparks. So for instance, you can't cut aluminum due to what's non-ferrous, it's ferrous, and you cannot cut an aluminum with a gas torch. So I hope that answers your question, but typically a MIG type glove, it's going to almost fulfill all your needs with a plasma torch.
Great. The next question we have and I'll throw this out to you all as well. Our attendee wants to know, do welding gloves and PPE have to go through any sort of approval to be sold in the US and or Canada? And maybe what should our attendees look for as far as approvals if they're looking for gloves or clothing?
Paul?
I was going to defer that one to you, Brian.
Hey, look, you said heads. Heads it is. Okay, you know what? I will answer it. Do you have to have it tested? No. Most of how we handle it, it is tested at the factory. So we know, we start with what we're looking for it to do, being an ANSI test or a comparable EN test for a cut. Heat as far as melting, say the TPR, we wanted it to pass certain tests because of the temperature range we are expecting it to hold up to based on an amp and volt level. So do you have to? No, but you have to start with some parameters in order to get a product to a certain level and why you're bringing it into the US.
Great. Thanks to all the folks sending in questions. Feel free to keep firing those away. We've got a lot of time here to get to some questions today. Paul, I wanted to throw this one out to you. When might using Kevlar be recommended?
Well, Kevlar, anytime it's going to be, again, there's going to be a need for protection for most of the time going to be for cut, jagged edges. So if we're referring to, let's say, a sleeve. So I didn't bring this out, but it's a good point to bring up where, let's say, example, a welder, fabricator doesn't need all the torso garments, but of course she needs gloves, but maybe a little bit more protection. So they may want to throw on a sleeve. So again, there's going to be double duty here. Like I mentioned, if you got the glove on and you also have a Kevlar sleeve underneath that goes up the forearm, of course, that's going to provide some protection against heat. But again, it's more so for any type of jagged edges. Again, just for the cut resistance.
Okay, great. Brian, we have another glove question that came in for you. And our attendee asks, with the new innovations in gloves, is a heat shield still needed?
It all comes down to what your power output level, thickness of material you're cutting with a torch. It comes down to, if you're cutting on it with a hand torch, you're cutting 6 inches of material. There is not a lot of gloves by themselves without a heat shield that you would wear and feel comfortable. A shield adds, basically it increases the level of tolerance in a glove while still maintaining dexterity. So yes, I think as time goes on, there are products out there. We're fortunate we have them. That's called aerogel. Even with aerogel, which is used as a protective layer on the SpaceX ship, and it was actually even used in the original space shuttle. Even with those technologies, a shield is sometimes needed. It tends to base off of what temperature ranges are you working in.
Great, thank you for that, Brian. Paul, next question to you. Do other brands currently incorporate 3-dimensional designs?
Good question. When it comes down to welding brands out in the marketplace today, other than PIP, there's maybe 1 or 2 other brands that are truly incorporating a 3-dimensional design, which is kind of interesting. 3-dimensional designs is not something that has been that just popped up. If you look at other markets, sometimes outdoor products, ski gloves, mountaineering gloves, a lot of brands out there have this three-dimensional design. Why it took so long to be incorporated into a work glove versus a leisure glove, where a worker can take advantage of all the benefits of a three-dimensional design, is beyond me. But to answer the question, there's not many out there, maybe one or two, that's it.
Gotcha. Thank you for that. Brian, you mentioned silicone as a new kind of up and coming material. And I know we talked about Boarhide as a new up and coming material. Are there other technologies in gloves and clothing that are kind of on the way up?
I think the cut level is here to stay, and I think you will see a lot of end users, not necessarily the big ones, which are driving the change now. I think you will start to see those materials pretty much blanket the industry here in the next, say, within the next 5 years. Cut level is, it's one of the questions I ask our development team, and that is, what does an A4 mean in the real world? I would definitely say leather is something that will probably be around, I can't say forever, but different leathers. So we have been using a lot more buffalo lately, and the abrasion resistance to buffalo is very similar to pig. So I would definitely say other animal hides finding its way into the fray it should be expected from everybody. The design features, I definitely think you're going to see a lot more back of hand protection as well as padded palms.
Great. Thank you for that, Brian. Appreciate that. We had another question come in from an audience member. Is ANSI puncture resistance going to be implemented more in the future as well?
Hey, Paul, do you want to do that quarter flip thing again?
That's a good question. It's hard to look into the future, but I think there's going to be a lot more regulation, I think, coming down when it comes to welding gloves. At this point, it's treated quite like a general purpose glove. Hey, just make an assessment based on hazards and application. You guys pick and go. But there hasn't been a whole lot when it comes to specifics. So I think there will be more of that coming in the future, but it's hard to say.
And actually, we have implemented having puncture testing done on our gloves. Just to be specific, Dan, it's typically an averages around between a 2 and a 3. If you get the same liner would be an A4. A 2 or 3 is your more common puncture rating.
Great. Well, thank you for that, gentlemen. It looks like that's all the questions we have today, guys. We want to thank everyone out there for attending today's presentation, and we appreciate you taking some time to share your feedback via our survey. A special thank you goes out, of course, to our terrific presenters today, Brian Rush, Paul Sung, and Jim Hebner, and the entire team from our sponsor at Protective Industrial Products. This ends today's Safety and Health Magazine webcast. Take care, everyone, and have a safe day.